Yeah, good afternoon. I could wake you up, of course, everybody, after such good food, with my, let me say, ideas to design wine cellars. I could imagine that would be much better and more interesting, but however, I try to make another revolution. And this revolution, what I would like to show you here now, is something where a lot of cement producers got rumors in their stomach. We put water onto hot iron, and a lot of people are always scared to do so. But I can convince you and explain to you that this is proven technology, and later on I will come back to this issue, of course, as well. Very short. Who is KIMA Echtzeitsysteme? And thank you very much, Rob introduced already. We will be named just next month only, not KIMA Echtzeitsysteme anymore, but KIMA Process Control. The reason is very simple. Echtzeitsysteme means, in English, real-time systems. This is, of course, a functionality of automation of control, which is, of course, good. But if you have 98% export in your company and nobody of your customer can explain what your name means, it makes sense to change it after 22 years. Okay. KIMA is, of course, well known, KIMA Echtzeitsysteme so far, for mill optimization. And mill optimization is the core competence still we have over decades now in our house. More than 700 optimized ball mills are the result of a very successful software development called MillMaster. The MillMaster is one of the software solutions we have designed from a software package called Smart Control. Smart Control is mainly based on digital filters, predictive models, but also on fuzzy control. We believe in this most robust, advanced process control and still offer that very successful to the cement industry. We have had also the necessity, I must say, to design new sensor devices. Why? Yesterday we have learned from ABB that, of course, soft sensors are here and they're used. Soft sensors are only as good as the input information again. So if you are able to design, based on a new physical function, a better signal, a better information from a process, like we did with this smart fill sensors, which you see just here, which are installed on the mill body itself, then you are able to have much more reliable, precise information. So what is going on in this mill? And I can tell you that we have calculated that and shown that in many places that the smart fill electronic ear is 10 times more accurate than the conventional microphone systems. This only for the introduction of our company. Coming now to a thing which is, of course, obviously happening in more and more cement plants in the world. It's, of course, the introduction and implementation of artificial fuels. AFR, alternative fuels, I wanted to say, not artificial. It begins then, of course, with complex burning conditions. If you change the fuel types and you change your burning zone behaviors, it comes very often along that at an earlier stage than earlier, the refractory material becomes thinner, earlier than expected. And at this moment, the people in the plant are fighting with coating drops. Why? Because the flexibility of the kiln increases. You don't have this stability, this corset of bricks anymore in your kiln. And then, of course, with these coating drops you create hot spots, not even red spots. The hot spot comes before. And I speak about temperatures below 500 degrees, and I will explain you why. If it is above 500 degrees or even 470, it depends on the company, let me say, rules, you are fighting with an unexpected kiln stop. Because if a brick falls out, you are not able to operate your rotary kiln forward, you have to stop it to prevent it from damages. So such an unexpected kiln stop creates costs. And the main costs are, of course, loss production. And a production rate for this case here, 4,000 dpd per day, and an assumed sales margin in the cement of $11 per ton, you can say that you have, in an emergency stop, around 6 days which you must stop the kiln. If it is only 4 days, it's even enough. We speak here about losses of production only of $250,000. However, today, to avoid such unexpected kiln stops, the plants are using huge fans, and these fans are everywhere. And to protect for thinner refractory, when these electrical fans are in operation, you must fight, of course, with a very, very high power consumption. I will give you an example calculation just in the next slide. The other disadvantage from fans is their noise. In Germany we have plenty of plants which are coming closer and closer, or different. The houses come closer and closer to the plants. That, by the way, was the reason that Heidelberg Cement in Enningerlohe, the plant in North Rhine-Westphalia, in conjunction with the German Cement Producers Association, VDZ, decided to contact KIMA Echtzeitsysteme to develop a solution for that. We did, and I would like to bring you exactly this on the point. What is more efficient than an air fan? Of course, it is water. But water on a very, very careful basis. What we do here is not artificial intelligence, it is artificial rain. We make a very, very smooth water mist, and this water mist creates on the surface of the kiln nothing else what we have as humans as sweating on our skin. The water touches the iron and completely evaporates. Only in this moment we can take out the energy. So we want to touch, but with very thin and smaller than 1 millimeters, by the way, drops. So this technology offers us a big step, because this technology measures first the temperature of the kiln shell, so that we can cool only there where necessary. In conjunction, or in comparison, that's the right word, in comparison to an electrical fan, this gives a lot of new opportunities. As long as we operate under temperatures of 600 degrees, and I must say we are working here with a controller which does not open the magnetic valves over 500 degrees, only to be on the safe side, so we don't cool red spots. You can't make anything wrong. The microstructure of the steel will be not harmed, because I don't know if somebody of you has made mechanical education during your engineering. There was this horrible ferrocarbon diagram. I hated it, really. It's everything. Everybody must go through this door. And but think about the curves which are there. You know all these names? I forgot them. However, the movement of these curves starts at 640 degrees. Below of that, one of the famous German cement producers, Salzgitter Mannesmann told me, below of this temperature you can cool your kiln with everything. With oil, with water, with air, it doesn't matter. No cracks, no harms, nothing. And whoever says that, it is a stomach feeling, it is not proven technology. We are engineers, and I hear much too often I've heard, this is danger for my kiln. Absolute wrong. So we designed the system more careful. We don't want to shock cool it. We don't want to cool as fast as possible. If you want to cool sufficient a kiln shell, we have taken only the air amount which is needed to cool 2 megawatt with a delta T of 40 Kelvin down. You need 150,000 cubic meters per hour of air to do so, and you need at the same time 3.2 cubic meters of water to have the same cooling effect, by the way, right? In 1 hour. Let us make more easy. If you have a kiln shell section of 1 meter and you want to cool it down 40 degrees Celsius, you need an air blower of 10 kilowatt. This produces 3000 non-cubic meters air. It has a noise of 105 dB. Try to imagine how loud this is. And I make the comparison now based on $7 per kilowatt hour. These are operational costs of $4,900 per year for 1 meter. The same you could do also with $50, because the amount of power we need for this controller is 10 watt. However, the main issues are, of course, that the noise emission is much less. Don't forget, noise is exponential. So this is a fundamental change in noise. We need for this 60 liters of water, and we do this with a control loop. That means what you have seen, the amount of water what I have described so far, is the maximum when the system would cool always the entire circumference. So you can collect and calculate that it is less than 30% than that what I have given here. However, the system has this infrared temperature sensors, there is the controller, there is an operation panel, and there are these water nozzles. What we need is 3 bar of water pressure. We don't make the atomization of the water with air. Only the water pressure is enough. If you don't have 3 bar, we say always make a basin at 30 meters at your preheater tower, then you have 3 bar. So now this absolute easy handling. By a rotary knob, you adjust your target temperature, which must be below 500 degrees Celsius. This is done very, very easily when you see in your control room your line scanner. So now where do you bring this system in operation? As I said, when it comes to the end of the production campaign and your refractory becomes thin, you easily go there where you have, of course, such high peaks or where you have a high delta T. What does a high delta T mean? On this circumference you have had some drops, so you have specific areas which are more heated, others less heated. In the next picture this is very easy to see. Over a couple of times the temperature in this region was increasing and increasing and increasing. So the operator said to his maintenance team, please move the kiln shell cooler to, let me say, 13 meters, adjust the target temperature of here approximately 330, 340 degrees, and the system is now spraying whenever this temperature is reached and above, not below. The effect is, compared to an air fan I show you later, that of course only this hotspot will be cooled. Another function in our controller is that we cool maximum 2 degrees per minute. Again, we have time. We don't want to shock cool, or we don't want to make it hurry, hurry, hurry. 2 degrees per minute means a very stabilized situation for steel, refractories and new coating development. So the mechanical tensioning, what you have usually when this hotspot is there, will be compensated, nothing else. I show it to you here. When you bring this bubble, let me say, this expansion steel back into place, you will have here a more stable situation. When this steel expands, the bricks become loose. When the steel will be cooled from outside, they will be shrinked. So it is like a clamp for the bricks. So you have more stable bricks again, and that gives the opportunity to have new coating formation. Now the comparison, what would be with air and what would be with water. On the left hand side the red circle, you see again here our small hotspot. Conventionally, you would go there now with an air fan. What would the air fan do? It would permanently cool. With this permanent cooling, you will make from this red curve, this red curve. You shrink the entire kiln and you have still your delta T. In comparison now to the KilnCooler hotspot, he is cooling only this part of the kiln. So he pushes inside, if you like, this bubble, this effect, and brings down the delta T. What you see in this picture is a system installed in J.K Lakshmi Resato on a white cement kiln. This is a stationary system, and in the meantime we are working here on 8 meters complete length, and it's not portable compared to that what you have seen earlier. This customer believes 100% in this technology. Another plant, they are using this, again, I would say emergency or mobile system to move it wherever it's necessary, easy, on a monorail. Very nice solution. What happens with your kiln when you spray water with a bit of limestone inside on your kiln? It becomes white. Wherever you see a zebra kiln, the KilnCooler is in operation. We have designed and painted a lot of kilns in the meantime, 30 globally. So 30 installations globally are the success, and I can tell you that I get today in the morning an order for the first KilnCooler now in the Arab region. It will be now installed in Dubai at JK Cement. Why? Water is very limited, of course, also in these desert regions, but the effect, what you can do to prevent unexpected kiln stops is so high valuable that also these customers are jumping onto the train. I give you an example now, as reported also in the catalog, of course, from JK Lakshmi Cement, which was done already in 2016, when the kiln was running on a much higher temperature near tire 1 at 20 meter distance because of very thin refractory. The plant team said that it has become very thin and they have to do there something. However, we installed the system, and now let's see the temperature screen before we started the system. We have here a temperature of 397 degrees as peak. You see here on the thermoscan also this peaks. Just 1 hour after installation, we adjusted a set point, and that will be in the next slide always to see again, at 360 degrees, only to prevent this overheating. Nothing else. So the plant has had the necessity to come another 8 days in operation until they go into their regular maintenance kiln stop. With these pictures we have seen earlier, they would have closed the kiln much earlier. Here the system gives them sufficient time to bring the maintenance people on site, to bring the right refractory on site, to prepare the cranes, to prepare the kiln start. So this was after 7 hours, this was after another 7 hours, so 14 hours, and this was after 2 days and 2 hours. First coating drops come again. Now, gentlemen, ladies, this system is not a miracle, or don't create miracles. We are don't providing new refractory material into this kiln. This is impossible. However, we are able to give sufficient enough time and to prevent your kiln for damages. So, after 2 days and 18 hours, still we have these small peaks with 380 degrees, 380 degrees maximum after 3 days, 4 days, 5 days, 6 days. At the 7th day we have massive coating drops, and that's normal. At a specific time the refractory is gone, and then you can't prevent anything anymore, otherwise all the refractory material manufacturers would be very poor people. In this moment, of course, the system again was able to keep the system into operation again under full production load. I must say that, always under full production load. At the end, after 8 days and 13 hours, the customer was absolutely satisfied and said the KilnCooler was helping in the plant to extend the kiln operations for more than a week's time by developing a coating even after refractory had become extremely thin and usually would have been stopped. The plant was able to reach the plant kiln shutdown on 9th of May with all necessary refractory materials on site and ordered services and standby. The KilnCooler served definitely the purpose for which it was installed. And at the end I show you also some nice pictures from a commissioning latest in Colombia, Cementos Argos. They have purchased the system as well. A short video. This is a long dry kiln. System in operation. And you see very rarely the spray is only taking place, only there where necessary. And that is the big difference, of course, to the F-hands. This was one of their examples before installation. You see a relatively high temperature profile from here. And when they switched on the KilnCooler, now look, you see immediately the temperatures go down, and what you see here is exactly what we have seen yesterday from advanced process control. This is, of course, something which is unbelievable and never seen before. We control the kiln shell temperature. The next slide, very high temperature variations on one kiln segment. Low temperature and high temperature, very far away from each other. Now look what the KilnCooler makes out of that. And I think these are impressive pictures. These are impressive pictures also for the future. The customer said immediately, the KilnCooler helping the plant to extend kiln operation for more than 1 month by promoting development of coating in spite of having the refractory thickness less than nominal. The KilnCooler served definitely by the purpose for which it was installed. I say thank you very much. I hope you are so happy like Ivan. Ivan is the mechanical engineer in Jumbo plant in Argos, and you see he has bring here the KilnCooler in operation. He was absolutely satisfied. I can tell you, if you are an engineer like me, sales engineer, technical oriented, fascinated by new technologies, and you get such a picture by WhatsApp from your customer, this is success. Thank you very much for your attention.
Thank you very much indeed, Dirk, for a nice presentation and for telling us all about the KilnCooler system. We do have a few questions that have come in. They're questions that, if you like, you left unanswered, possibly to allow people to ask these questions. The first one is, what constraints do you have on water quality in terms of particulates? Can these cause nozzle blockages?
The nozzle opening, the hole of the nozzle, is approximately 1.5 millimeter to get a feeling. We have a particle filter in front, in the system itself, which prevents from particles less than 0.1 millimeter. So we didn't have had any effects so far. If you ask me for the necessary maintenance of such a system, it is exactly that you here and there clean the water filter.
Okay. Question from Anonymous. Is rust an increased issue for kiln shell maintenance when using water cooling?
Definitely no. You must say, or you must to consider that the system, we calculated that when it would be open 365 days a year, 24 hours, that would be less amount of water than 2.5 days of heavy rain. Try to imagine that. So it is like a higher humidity of air, not really more. Definitely no corrosion.
Okay, what is the water consumption per kiln per year?
That depends, of course, on the kiln and, as I said here, on the necessity, I would say, how much hotspots they have, how early they start. My recommendation would be not only to start with a system only over 300 degrees. Look, if you have a delta T of 40, 50 degrees, even at 270 degrees, it means that you have unstable coating over the circumference. So use it even in this moment to have a more stable coating from the earliest time. So I can't answer this question. What I can say is, if the system would operate full and permanent, which is not happening, again we will speak about 6 liters per minute. That's it.
Okay. Somebody's asking, how much does it cost?
No problem, we can speak about that. The system, let me say, let me show the picture. This system, as you see it here with 4 units, has a cost of 50,000 euros. And 50,000 euros are easily, of course, to be get out if you prevent 1 day of unexpected kiln stop. Only 1 day would pay 2 of the systems immediately. I give you an example. If you play with fire, with new fuels, whatever, you would have always your fire extinguisher close to you, right? I think such a fire extinguisher is an absolute need. If you start with alternative fuels in your kiln, you have no idea what will be the burning zone, what will happen there. And in this moment, to have a fire extinguisher who protects your shell would be a good idea.
Okay, and finally somebody's asked, is there a copy of this presentation on the USB stick, as the one in the conference notes is slightly different?
It is. I wanted to show you really the latest experiences. That is why I moved that a little bit along. If you want to have a copy of this original one, come to my booth, you will get it.
Excellent, excellent, great.
Bring a USB stick, please, then.
Okay. Well, you can bring the one that's in your conference bag, so you will definitely have
Exactly.
one. You will
Exactly.
definitely have one. Any questions from the real world in the room? Okay, in which case, let's join together and thank Dirk Schmidt. Oh, sorry. What? Oh, yes, please go ahead.
Sorry, simple question. What length of the kiln have you covered with that 4-spray system?
2.5 meters.
2.5.
It is approximately, each nozzle has a distance of half a meter, so we cover with one of these units approximately 2.5 meters.
The criteria they used to position that there was their trouble spot.
Yes.
I can understand the sliding system, but then you can't cover 2 trouble spots with one system.
Not with one system, then you need 2 systems. But let me drop this information also. The stationary system is much paying less. It's much, much cheaper.
Thank you.
Yeah? So we designed the system in the meantime per meter. And let me drop this information also out because I think it's interesting. There is already the next generation. And this next generation of this KilnCooler spot hot the system is worldwide patented, by the way, is also even patented. Underneath of this sensor, this optical sensor which measures the temperature, will be in future a laser distance measurement. With this laser distance measurement and a stationary cooler which is provided over the complete length of the kiln, you have the temperature profile, you don't need your thermoscanner anymore. And secondly, you will have the ovality of your kiln per half meter. Now try to imagine what that means in future. It means wherever you have a coating drop, immediately the system will work. Wherever you have a disalignment, the system can be programmed to make this realignment full automatically with the hot turning kiln. This is the future.
Maybe next year.
Not next year, it will take, I would say, at least 5-6 years to get.
Okay. Let's see. Yes, one more. Last one.
Yeah, have any of the kiln designers installed this from you?
Please again, kiln designers?
Any of the kiln designers, any of the kiln suppliers have installed this from you?
No. Why? We prevent that the kiln is damaged. these kiln suppliers, of course, are happy to sell the one and other kiln section. And they are more happy to sell kiln sections maybe with rollers. I have no idea. No. So far there is a big, as I said in the beginning, there's a big conflict of putting water onto this hot iron. But I think we will solve that. By the way, very interesting, in LinkedIn, last week only, I've had a very interesting discussion when somebody puts a picture inside from Japan. You know how the Japanese cool their kilns? Since 100 years? With water spray. But without control. They make it continuously.
Okay, we're going to hold it there. Once again, Dirk Schmidt, thank you very much.